So I've got this part B here, and I've got this rate equation that I've come up with, and this is based on the data that I came up with in part A. But I want to point out that 1, 2, and 3 here, these orders, they're not necessarily what you would find. This is just for illustration's sake. So we came up with this k value here of 780 m to the negative 5 s to the negative 1, and I'm going to now go through how you would determine all the information in part B. So for part B, the first thing you would do is you'd figure out these times here, and the times would be what you would just do with the regular reactions. I'm going to come up with two of these. We'll do 360 and we'll do 370, and we'll put them at 22 degrees Celsius each. Say 22.0 degrees Celsius, 22.0 degrees Celsius. So these are experimental results. And that's important. You actually found these by doing an experiment. Alright, that's really important. So the average time, that goes down in here, the average experimental times, and that would be 365 seconds. Okay. Actually, I don't need to put seconds there because it's already in there. So 365 seconds is what I've got. The next thing I want to do is figure out this predicted reaction rate. Now, to get that, I do need to find these molarities. The first thing I'll do is I'll figure out the molarity of the acetone. And that's going to be 15.0, whoops, we'll do this the way I did it before. We'll do 4.0 molar, that's the stock solution, times 15.0 mils, divided by the total volume, which is still 50.0 mils. And you get that 15 plus 15 plus 10 plus 10 is 50, which comes out to be 1.2 molar. So that's what's going to go in here, 1.2 molar. The HCl I'll do in the same way. That's going to be 0.30, and the iodine is 0.0010 molar there. Now I'm going to figure out this predicted reaction rate, and to do that I'm going to use the information I came up with in part A. So all of this is from part A. But again, remember, a lot of this is made up information. It's not going to be what you would find. So what I'm going to do is write this down. So predicted rate now. Now this is as opposed to the experimental rate. The experimental rate we found by experiment. This is what we're finding by doing some math. So predicted rate is going to be K. So it's acetone, which is going to be 1.2. Well, I'll just go ahead. Actually, I'll go ahead and write this down completely before I go ahead and sub stuff in. So it's going to be acetone, HCl, acetone to the 1, HCl to the 3, I2 squared. And we're going to substitute in the values we got from part A. So that's 780 m to the negative 5, s to the negative 1. That's for K. Now the acetone, that's going to be 1.2 molar to the 1. And we've got the HCl, 0.30 molar to the 3, and 0.0010 molar squared. And the predicted rate then is going to be what we'd figure out from that, which would end up being 2.5 times 10 to the negative 5 molar per second. So you can see that all the molarities will end up cancelling. We'll be left with m here and per second here for the s to the negative 1. So that's the predicted rate. That's what actually we're predicting to find. Now this is a little bit complicated because it's a bit confusing. We've got this other time that we're going to come up with, but we know what the predicted rate is. The predicted rate is actually linked to the disappearance of the iodine. So it's the change in concentration of iodine over the time. but the key is here, it's the predicted time. Now, predicted time is what we're going to be looking for. So predicted time is going to be the concentration of I2, change in concentration of I2, divided by the predicted rate. So that's just from rearranging that equation. Now the concentration of I2 here is 0.0010 molar. The predicted rate is what we got up here, 2.5 times 10 to the negative 5 molar per second. And that comes out to be 400 seconds. So what does that 400 seconds represent? Well, it represents the time that we would predict it would take in order for this reaction to occur. All right, that's what that's going to be looked at. So the predicted reaction time, so predicted reaction rate is 2.5 times 10 to the negative 5 molar per second. The predicted reaction time is 400 seconds. And you can see here, we can compare now the predicted time, which was 400, to the experimental time, which was 365. So understand that experimental time is something we found from experiment. We didn't get that by doing any math. We got that just by observing what happened with the reaction. The predicted time, however, we got by doing some math, knowing some of the values we had already gotten from Part A. So that's what we're trying to do here. And you should see that the average experimental time should be fairly close to the predicted reaction time, even though it's probably not going to be exactly the same.